should be good. There we go. Hello everyone and welcome to CSC 151. In this video, we will be going over the concept of computer language and the history of computer language. So, for anyone that wound up taking this class, and it was either this or a language class, my apologies, but this is a language class. Computer language has their own rules and syntax just like any other language. We will be getting more in depth with those rules and syntax and structures in later videos. But for this video, we're simply going to work with this pyramid that I have labeled from 1 to 6. So, has anyone ever had one of those scenarios where you'll probably see this in a math book of some sort, where Farmer Joe wants to sell his cow, and he wants to buy a horse, but the person selling horses, all the way over here, at the bottom, doesn't want to sell his horse for a cow. He wants 3 pigs. Well, the person that wants to sell pigs doesn't want a cow either, or a horse. He wants, 10 chickens, and so on and so forth. And you wind up getting this sort of scenario where, if this were languages, let's just say we have English at the top, and at the bottom we have someone that speaks Japanese, but we don't have a direct intermediary that speaks both English and Japanese. So we have to find someone that speaks English and Spanish, and then we have to find someone that speaks Spanish and German, and then we have to find someone that speaks German and, French. And then we have to find someone that speaks French and Mandarin Chinese. And then, of course, there'd be another step in there from Mandarin Chinese and Japanese. And now we finally have ourselves a way to get from English to Japanese in the most roundabout way possible. That's basically what's happening in computer language. Just replace the words English and Japanese with human and computer. Because if we really think about it, we are humans. We are flesh and blood. We require water. We require air. That sort of stuff. And then we have the computer. The computer is literally made out of sand and rocks. Lithium, silicone. It's literally made out of the ground. Different kind of concepts altogether of how we talk to one another. So I'm just going to bring these steps back in between, and here we go on to how do we get from us to them and vice versa. So not only are we tracking, this goes through, but we're also tracking time. Okay, so I want you to imagine that this is like the year 1920-ish, okay? And up at the very top, at the time of making this video, it's the year 2022. So we're also taking into account about 100 years worth of time and modifications into this process. So I'm going to keep human up here, but the computer is more specifically made out of hardware. It's made out of stuff. Circuits, chips, silicon, it's made out of sand. Maybe you might have a fan or a water coolant system or something or other, but it's made out of stuff. And this is where we get to go and say, what does that stuff run on? Because you can't just type into the sand, hey, I want you to, go and Google this for me. The sand doesn't listen. The sand is literally sand. It has no components like that. It's just sand. So that hardware has to run off of something specific. And that something specific is electricity. Your computer is a machine. It's either on or it's off. A light bulb is either on or off. Your television is either on or off. And that on or off is known as binary. It's also known as machine language. Okay? Now, what does binary mean? I am glad you asked. Let me go and Sorry, that was just me trying to figure out roundabout ways as to why my QuickTime was breaking all of a sudden. But, binary language. Binary language is literally ones and zeros. There it is. 1 0 0 1 1 0 1 1 1 0 0 1 0 0. That's binary language. At the base level, at the very base understanding of computers, that's what your computer reads. That is its code. The ones represent on, the zeros represent off. Or you could think of it as true and false, yes and no. There's only two possible options, binary, two states. So that's what the first ever computers ran off of. And if we look at the first ever computers, now what it actually considers the first ever computers is up to anyone's guess. This is not the first ever computer. This is something a bit more accurate. This was a tube computer. It had tubes filled with chemicals inside of it. That was literally how it processed things. You would have entire rooms of these computers. And obviously, if something broke, you had to replace the tubes one by one until you found the tube that was not working properly. But these were the military secrets. These were the year 1920-ish, and their entire job was to intercept and translate and figure out, just by grinding out every possibility, figure out enemy transmission and codes. That's what their job was. And at the end of the day, the only thing they did was they printed out on a little piece of paper a little ticker tape. And that ticker tape would go dot, 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 no dot, 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 no dot. It was binary. It was two states. Binary. Now, obviously, if this was the type of computer you were working with every day in your life, how many of you expect that this would be the type of computers you'd be using? Yeah, no, this would not be mass market appeal if this was the history of computers in a nutshell. And then we had to change stuff about it. Don't double click. We need to change into assembly language. An assembly language is basically what it sounds like. It assembles the binary. If we want to see an example of this, let me go and say assembly language. There we go. And assembly language is basically reverse this image, and you'll get an assembly language. The arrows can go both ways. But we've got the 1 0 0 1 0 1 1 0, and what we have over here is the assembly language. MOV, ECX, EBX, MOV, ESP, EDX, so on and so forth. They were short little codes that were typed line by line in order. This is before we had ourselves GUI systems. This was before we had a mouse. This was before we had any sort of visual component. This is still, dawn of computing here. And we had these short little symbols that meant these ones and zeros. They translated the ones and zeros into this short little code. Now, why were the codes so short? Well, here's me showing my age here, but does anyone here remember a floppy disk? You might have had something like this, where they literally only held, okay, that's a hack. A floppy disk would not hold 118 gigs, but these little floppy disks were, this was memory storage in computer class in grade school for me. But this floppy disk right here, this archaic piece of technology for all my students, this one floppy disk had more computing power than those gigantic room-sized computers you saw in the previous pictures. That's why the code had to be so small. You had to save space. You had to save space in order to not run out of space. Because you ran out of space, well, you broke your computer. You had to get rid of it somewhere. You had to find new ways to make space. So, the more letters you used, the more space you used up. So that's why the first ever computing languages were very teeny tiny. We've gotten more advanced with that. We've gotten to what's known as high-level languages. Name any sort of computer language you've heard of. HTML, that's your websites. JavaScript, also very common in websites. Python, very common learning tool, and also used in other programs as well. C#, if you play video games, a lot of your stuff is in C#. Or C++, also high-level languages. Name any sort of language you've heard of, chances are it's a high-level language. You want a very easy way to figure out the code of a website? Just right-click it and go to View Page Source. You will literally see the HTML that makes up that website. You can see the high-level language. And in between that, we also have ourselves our good old friend applications. Because what am I in right now? I'm literally in an application. I'm in Microsoft Word. I'm using an application. This application is the visual representation of the high-level language code. That high-level language code was built on top of the assembly code. That assembly code literally translated the binary code. And that code was understood by the hardware. So every single time I click something, click, 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 and it's doing something instantaneous, my computer is basically translating from human to application to high-level language to assembly to binary to the machine. And then back to binary, assembly, high-level language, application to show me, the visual element that my eyes as a human understand. And that is, that is basically the coding pyramid from the year 1920-ish to the year 2020-ish. 100 years difference, and here's the language translation that's always going on. Now, as I said, we will be talking more about this, the nitty-gritty details about how these languages work and what their actual rules and functionalities are later on as we get into actual coding. But we're going to be going over the basics this week, and the next video, if I did this in a way that I have written out on paper here, will be about how computers talk to computers. Please remember to watch every video before you decide to move on to the follow-along assignments or to do your independent assignments. Because, trust me, the videos that you see right here will be giving you information that will be needed in those assignments and on the quiz. So, make sure you pay attention, take notes if you have to. Thank you very much. I'm going to hope this works, and if it does, I'll be making a bunch more videos today. You have a great day, everyone.